Hello everyone, my name is Evan Shibu. I'm a student of University of Wollongong, Australia. This is a research that I have done on production of multi-layer metal alloy plates. In this presentation, we can see that the use of additive manufacturing in the process of production of multi-layer alloy plates. Additive manufacturing is also often known as 3D printing. It's a process of constructing three-dimensional items by building them up layer by layer rather than just moving like bigger blocks from the original material. The primary advantage of additive manufacturing is that its design flexibility and it has a very reduced waste production, and its ability to create incarnate structures that would be challenging, or we can say that it is impossible to produce by a traditional method. So these are the major advantages of making a product using additive manufacturing. Talking about the literature review in this paper, we can say that it discusses more about wire additive manufacturing, which has developed a potential process for producing more complicated metal components such as magnesium alloys. And they are the main advantages of these magnesium alloys are they are super lightweight and they have high specific strength. The literature review also discusses about the optimization of microstructure and mechanical properties of wire additive manufacturing fabricated magnesium alloys to emphasize the current advances and challenges. And the recent researchers have highlighted the importance of process parameters such as heat input, wire feed rate, the travel speed in shaping the microstructure and the mechanical properties of the magnesium alloys which are produced by wire additive manufacturing. However, something the gap I found in this literature review was it was not talking about the effect of cooling parameters which could change the microstructure and the mechanical properties of the material produced by this. That's not clearly mentioned. Next, we can move into the research question and objectives. We can see that the research question is that how does optimization of microstructure and mechanical properties affect wire additively manufactured magnesium alloys? To find an answer to our research question, we look into an experiment which uses different cooling strategies like air chilling, water quenching, rapid cooling to make microstructural and mechanical property changes in magnesium alloys, and we examine the changes which happen in the material according to the parameters we changed. Total 16 trials were carried out at various conditions. There were 8 single layered and 8 multi-layered samples. We used different heating inputs and cooling media for IN718 alloy. Let's look into the observations we found out by that experiment. The microstructural characteristics and mechanical properties were evaluated by bead geometry measurements, optical microscopy, scanning electron microscopy, energy dispersive spectroscopy, electron backscatter diffraction, etc. And we examined the various mechanical properties like Vickers hardness and tensile strength. The researchers were able to identify the changes in microstructure and mechanical properties according to the changes we made in the parameters. And this method revealed important insights on optimizing manufacturing conditions for IN718 alloy. Going into the discussions of this research, we can say that the researchers were able to investigate how the parameters affect the final properties of the material produced, like by varying the heat input and the cooling strategies, how this affected the material properties. This method actually revealed important insights on optimizing manufacturing conditions for IN718 alloy. The problem I found out in this experiment is that the experiment is very detailed and complicated. So the complexity could lead to the influence of other factors, which makes it hard to know whether the results are accurate or not. So we can say that the research helped us to identify the effect of the cooling parameters and the effect of cooling parameters in microstructural and the structure of mechanical properties in the materials.